Hello students, welcome to online maths classroom. Today we are going to take up exercise 6.5. So let us start with it. Question number 1 of your exercise 6.5 is find the maximum and minimum values if any of the following functions given by. Okay, the functions are fx is equal to 2x minus 1 whole square plus 3. So let us start with it. So this is your function. Now we know as C that this is 2x minus 1 whole square. This is a square. Okay, and you know that it will always be positive, greater than equal to 0. Now if I'll add 3 to both sides, okay, to make this function, what I will get that term will also be greater than equal to 3. Okay, so that means the function, this is my original function, this will be greater than equal to 3. Greater than equal to 3 means the minimum value of the function is 3 and is obtained when it will be obtained when this term will be equated to 0. Okay, so minimum value of the function is your 3 and is existing when at the 0 of this, that is when x is your half, and the maximum value of fx is equal to 2x minus 1 whole square plus 3. It approaches to infinity. Okay, as x approaches to infinity, and hence we say that the maximum does not exist. Okay, similarly in question number 2 of this function, what I need to do is I have to express it as a perfect square. So take out 9, then you have to just say this 12x by 9 can be written as 4x by 3. Then you know you have to add half of square of coefficient of x to both sides. Okay, this term makes it as x plus 2 by 3 whole square, and on solution of this you will get it as say minus 2. Okay, because 9 is outside, so 2 by 9 minus 2 by 9 will give me minus 2. So as you know, now let us interpret it. This is always positive, and when you will subtract minus 2 from it, it will be greater than equal to minus 2, because in minus 2 you're adding a positive number. Okay, so which is greater than equal to minus 2. So again this minus 2 means is minimum and will be obtained at the 0 of this, that is at x plus 2 by 3 equal to 0, that is when x is equal to minus 2 by 3, and the maximum value is again, okay, as x approaches to infinity, this fx also approaches to infinity, hence we see that the maximum does not exist. Next is your again same function. This becomes your again this x minus 1 whole square is always positive. Okay, now when you will multiply it by minus 1, you know the sign of inequality will change and it will become negative, less than equal to 0. Now add 10 to both sides, you will find that this complete term is less than equal to 10. So that means function is less than equal to 10. That means the maximum value of the function is 10 and is obtained when x minus 1 is 0, that is x equal to 1, and the minimum again is not existing. Okay, the last one is x cube plus 1. Now as you know, x approaches to infinity, your this function approaches to infinity, and if it approaches to minus infinity, this also approaches to minus infinity. So in this case the maximum value and the minimum value both do not exist. Okay, the maximum and minimum do not exist. Number 2 is find the maximum and minimum values if any of the following functions given by. Now the functions are your fx equal to x plus 2 minus 1. So let us start with it. Now you know for every real number x belongs to R, this modulus term is always positive, greater than equal to 0. Now subtract 1 from it, both sides, you will get it is greater than equal to minus 1. That is your function is greater than equal to minus 1. So that means it is the minimum and is obtained when this your x plus 2, this is equated to 0. Okay, it is equated to 0. So that is at x equal to minus 2, and maximum again not existing as fx approaches to infinity, as x approaches to infinity. Okay, and hence maximum does not exist. For the second case, again mod is positive, but negative times of it will be less than equal to 0. I'll add 3 both sides, so it will be less than equal to 3. So less than equal to 3 means it is the maximum value is 3, and the minimum again does not exist. Next is your hx equal to sine 2x plus 5. Now you know that sine function, whether it is of any angle, either it is sine x or 2x or 3x, it is maximum value is 1 and minimum -1, means it ranges between -1 and 1. So to make it like sine 2x plus 5, I will add 5 both sides, okay, throughout. So it becomes hx is your, this is 4 and this is 6, means it is lying between 4 and 6. So both maximum minimum exist. So minimum one is your 4 and the maximum one is 6. Again for the second one, your again for x belonging to r, sine 4x, here it is lying between -1 and 1. Add, you have to add 3. So it becomes sine 4x plus 3 is lying between 2 and 4. Now since we are talking about mod, so as there is no negative term, but what I will do is I will take mod throughout. So all the terms are positive. That means my fx is lying between 2 and 4. So minimum value is your 2 and the maximum value of the function is 4. For the last one, hx is equal to x plus 1. X belongs to -1 to 1. Okay. So x is lying between -1 to 1. But my function is x plus 1. So I'll add 1 throughout. So it becomes x plus 1, or my hx is lying between 0 and 2. Okay. So hx is greater than equal to, see here, this is we are talking about the open interval. Okay. So is greater than 0 and less than 2. And you can see from all these that we have to see the sign of greater than equal to or less than equal to. So in such case, we have to take that it is neither minimum nor maximum. Okay, as we say that in both sign of this equality is missing. Okay. Now number 3 is find the local maximum and minimum if any of the following functions. So let us start with it. We are going to use second derivative test. So function is your x square, first derivative 2x, double derivative 2. It is existing. To find critical point, put f dash x is 0, x is 0. Now let us apply the second derivative test. How to apply? Check this value of second derivative at x equal to 0. So you find it is positive. It is always positive as x is missing here. So that means if a double derivative is positive, we know it is the local minimum. And the local minimum value can be obtained by putting x equal to 0 where? In fx, which is turning out to be your 0 itself. Okay. Second one is x cube minus 3x. The function is derivative is 3x square minus 3, double derivative 6x. To find critical point, put g dash x equal to 0. I'll get it as your x plus 1 equal to 0 or x minus 1 equal to 0. That means it is -1 or 1. So let us apply the second derivative test. So the value of g double dash x at -1 is -6, which is negative, and your this x equal to -1 becomes point of local maximum. Okay, and the local maximum value can be obtained by putting g of -1. So that comes out to be your, here we take the value as it is 2. Now at x equal to 1, double derivative is positive, so means it is the point of local minimum, and the minimum value is g of 1, which is -2. Okay, so this is how we can obtain the local maximum and minimum values. Number 3 is your this trigonometric function. So hx is your sin x plus cos x, and x is lying between 0 and pi by 2. Okay, so h dash x is your derivative is cos minus sine, double derivative is minus sine minus cos. Okay, critical point we get, as you know, we take it to either side, we get it is tan x equal to 1. So between 0 and pi by 2, there is only one value which is satisfying, that is pi by 4. Okay, so I'll check this double derivative at this x equal to pi by 4, which turns out to be -2 by root 2, that is minus root 2, which is negative. So x equal to 4 is the point of local maximum in this case, and the local maximum value can be obtained by putting x as your root this value of pi by 4, that is we obtain it as sin pi by 4 plus cos pi by 4. Okay, so we get it as root 2. So this is your local maximum value. Next is your fx is your sin x minus cos x. So derivative is cos x plus sin x, double derivative is this. minus sin x plus cos x. Here on critical point equating to 0 we get tan x negative. Okay, as the interval is 0 to 2 pi, so I have to work out all the values where tan itself is negative, so that negative of negative cancelled will give me the value of tan positive. So we see tan is negative in my this second quadrant and my fourth quadrant. So second quadrant means 10 pi minus pi by 4, fourth means 2 pi minus pi by 4. So the two angles possible are 3 pi by 4, 7 pi by 4. When I'll apply the second derivative test at 3 pi by 4, I'll get the value like this, minus sign 3 pi by 4 plus cos 3 pi by 4, which is minus root 2, that is negative. And the value can be obtained by f of 3 pi by 4, which is coming out to be root 2. And again at x equal to 7 pi by 4, the double derivative gives me the positive value, root. And the minimum value will be obtained by f of 7 pi by 4, which is minus root 2. Okay, now this is a cubic polynomial. Again the derivative, the double derivative. The critical point I'll obtain from here as x equal to 1 and 3. Okay, and first derivative at x equal to 1 is minus 6, which is negative. So local maxima, local minimum value is your f of 1, which is your 90. Okay, then when x equal to 3, double derivative is your 6, which is positive. So the minimum value is your 15. Okay, so at x equal to 1, local maxima is here and local maximum value is 19, and at x equal to 3, local minima is there and minimum value is your 15. Now gx is your x by 2 plus 2 by x. Derivative is your, you can use, it is half, and it is minus 2 by x square. After taking LCM, you'll get it in this form. So to find critical point, I'll get 2 critical point, minus 2 and 2. Now as x is positive, it is given, so I'll reject the minus 2 critical point. So there is only one critical point, which is x equal to 2. Now I'll apply the second derivative test. Okay, but second derivative test I'm not going to apply, as I have to take the derivative up to this here again, means it will be going to be quite tedious. I have to again apply the quotient rule. So it's better, let us see how to apply the first derivative test. So I have to pick up two numbers. One is say less than 2, that is x 1.9, and one is the number that is 2.1. So I'll check g dash x. It is turning out to be negative, like 1.9 plus 2 is positive, this is negative, and denominator is positive, so result is negative. And at this 2.1, the derivative is your positive, means it is turning from negative to positive. So you see what is existing, it is your minima, minima is existing, and local minimum value is your g of 2, which is 2. Okay, now second derivative test, if we want to see it, say it is like 4 by x cube. Okay, d double derivative at this is your positive, so again we can say that local minimum is existing at x equal to 2. Okay, so this is how we can compute by taking whichever we find okay, we can go for that test. Okay, now here this function is at x equal to 1 upon x square plus 2, so we can take it like this. Now first derivative, this is second derivative, critical point is your 0. Okay, at x equal to 0, the second derivative test gives me negative value, so this is point of local maxima, and h of 0 gives me the maximum value, which is half. Number 8 is fx is x root 1 plus 1 minus x. Now derivative is this, double derivative is your, okay, double derivative is, you can go for if double derivative it is quite large, so we can go for this, as the critical point is x equal to 2 by 3, so we can apply the first derivative test. Say some number less than 2 by 3, let us say 0.6, we check f dash 0.6, which is positive, and for greater than this, that is x equal to 0.7, we find it is less than 0, so it comes from positive to negative. So you see it is point of your maxima, local maxima, and the value can be obtained by f of 2 by 3, that is 2 root 3 by 9. So similarly, your second derivative test, if you are okay with the second derivative, so take the second derivative, and the derivative at this 2 by 3 is negative, so it is the point of local maximum. Okay, prove that the following functions do not have maximum minima, like fx equal to e raised to power x. So let us take the derivative. To find critical point, put it equal to 0, but you find that e raised to power x equal to 0. Okay, but there is no real value of x which is giving me e raised to power x greater than 0. Okay, why is it so? As you know that x is a real number, so if I'll take, say, e is my number, some number which is having the value as 2.7, okay, 2.71, like this. So if it is, this power is, see, something negative, so this will be something 1 upon a positive number. So this result is, okay, it is always positive. It is never turning out to be 0. So in this case, there will be no critical point, and hence it does not have maxima or minima. For this second, gx is log x, your derivative is 1 by x. Okay, derivative put equal to 0, it gives me 1 equal to 0. So which is not possible. Okay, so no turning point, have no maxima minima. Hx is this derivative, critical point, you see here turning out to be some complex roots it is having. So the x values of x are imaginary, hence it does not have maxima or minima. Now let us check number 5, which is about absolute maxima and minima. So how do we do it? Take the function, okay, take the derivative, take the critical point. It is x equal to 0. Now to find the absolute maximum and minimum, I should check this function, the value of the function, okay, function fx, at where? At this critical point 0 and at the endpoints like -2 and 2 both. So at x equals 0, f of 0 is 0. We check f function, not derivatives. And x equal to -2, it is -8. X equal to 2, it is 8. So the minimum value is here -8, and the absolute maximum is 8. Now for question number 2, we find that your fx is sin x plus cos x, okay, between 0 and pi. So this is derivative. Critical point is again your tan x equal to 1, which gives me pi by 4. Only one value between 0 and your pi. Okay, so I have to check my, as it is absolute, so I have to check f function at 0, pi and pi by 4. So we find after applying it that your absolute minimum value is -1, okay, and maximum value is your under root 2. Okay, again this is a function, take the derivative, critical point, okay, the critical point 4 definitely is lying between this. So I'll again check the function, my function at 4, -2 and 9 by 2, okay, and absolute minimum is -10 and maximum is 8. Number 4 is fx is x minus 1 whole square plus 3, okay, and x belongs to -3, 1. Okay, so this is the derivative. Okay, the critical point is your 0. Putting it to 0, I'll get x1, which is lying between -3 and 1. Okay, now I have to check my values at 1, -3 and 1. So I'll get the minimum value is 3 and absolute maximum is 19. I have to check the function. Number 6 is find the maximum profit that a company can make if profit function is given by this equation. So as there is no interval given here, so this is the question of local maximum or minimum. Okay, local maximum. So here I have to find the critical point and I'll apply the second derivative test. So here the profit function is px, the derivative, double derivative, okay, the critical point x equal to 2 by 3. Okay, now I have to check my second derivative test the derivative at x equal to 2 by 3, which is negative. So which is local maximum. And the value can be obtained by putting P of 2 by 3, which turns out to be 49. Okay. Now number 7 is find both maximum value and the minimum value of the function on the interval 0, 3. Okay, so this is the function, this is derivative, this is critical point, x is plus minus root minus 2, this one is rejected, okay, and this x equal to 2 is retained. It is lying between 0 and 3. Okay, so as it is the question of absolute maximum minimum, so I'll check the function where at 0, at 3 and at 2. Okay, so I'll get my minimum absolute value is minus 39 at 2 and maximum absolute value is 25 at x equal to 0. At what points on the interval does the function attains maximum value? This is my function, this is derivative, critical point is your, okay, by putting it equal to 0, and see I have to take all the critical points between 0 and 2 pi. So I'll get these 4 points, all are belonging to this. Okay, so now I'll check my function at all these points. Okay, so I get that this function attains maximum value 1 at pi by 4 and at 5 pi by 4. Okay, so the required points of your maximum are pi by 4 to 1 and 5 pi by 4 and 1, as it is getting at both points the same value. What is the maximum value of the function sin x plus cos x? Okay, so here the function is sin x plus cos x, the derivative is cos x minus sin x. To find critical point, put f dash x equal to 0 and we get x as pi by 4. Okay, so in general we take it as pi by 4. Now here, since no interval is defined, so I will take the as your value of x is your n pi plus pi by 4. Okay, this is, we know when tan theta equal to tan alpha, then theta is n pi plus alpha, as n belongs to z, as it's a general result. Okay, so what is f of n pi plus pi by 4? That is your sine of this plus cos of this complete angle, and which gives me the value of something like minus 1 raised to power n root 2. Means depending upon the power of n, if it is even then it is negative times root 2, if it is odd it is, okay, like this, it is odd, it is minus root 2. Okay, so maximum value of the function is root 2 and the minimum value is minus root 2. As it's a general question, so we need to go by general method. Number 10 is find the maximum value of the function in the interval 1, 3. This is 2 parts and then you have to check in the other interval. So start with the function, the derivative, the critical point, x is equal to plus minus 2. Okay, now to check the maximum in this interval, I have to evaluate my function at 1, 2 and 3. Okay, as this point minus 2 is not belonging to my interval 1, 3. Okay, so you have to check all these values of the function. For x equal to 2, I'll get the value as 75. So at x equal to 1, f of 1 will be your 85, and at x equal to 3 it is 89. Hence the maximum value of the function is 89 at x equal to 3. Okay, and when we will find the maximum value in interval minus 3 minus 1, okay, now here minus 2 will be satisfying this, the other critical point, and x equal to 2 will not be lying in it. So we will check the value of the function at x equal to minus 2, minus 3 and minus 1. So we get the respective values like 139, 125 and 129. Hence the maximum value is 139 at x equal to minus 2. It is given that x equal to 1, the function attains its maximum value on the interval 0 to. Okay, find the value of e. Now you know that at x equal to 1 the function is attaining its maximum, means that it is the critical point, and critical point is that point at which the value of derivative is 0. That means like in this case f dash 1 will be 0. Okay, so this is a 1 mark question. So we'll do it like this, like fx is this. So this is your derivative. Okay, since fx is attaining this at x equal to 1, it is attaining its maximum value, and moreover this 1 is also belonging to this interval. That means f dash 1 is 0. Okay, so by putting here at x replacing by 1, we'll get e as 120. Number 12 is find the maximum and minimum value of the function x plus sine 2x in the interval 0 to pi. Okay, so this is the function, here is the derivative, and the critical point is your, we get f dash x equal to 0, we get here angle minus cos pi by 3. Okay, now which is the nearest angle is cos 180 minus theta is minus cos theta, so it is 2 pi by 3. Okay, and we have to find all those angles which are satisfying in 0 to 2 pi. So we know the formula for cos theta is equal to cos alpha, then theta is equal to your 2 pi plus minus alpha and belonging to z. So at x is your 2n pi plus minus your pi by 3. Okay, for n belonging to z, it is 2n pi. Okay, so when I'll take it as say 1, taking the value as 1, I'll get it as pi by 3, then it is 2 pi by 3, then it is 4 pi by 3, then it is 5 pi by 3. All the angles are belonging to 0 to 2 pi. Okay, now I will evaluate my function to get the absolute maximum at all these points, at f0 and at endpoint 2 pi. So out of these, when I'll evaluate, I'll find that absolute maximum is occurring at x equal to 2 pi and minimum at your 0. Number 13 is find two numbers whose sum is 24 and whose product is as large as possible. So we'll start with the first number x, second is y. So as x plus y is 24, so y becomes 24 minus x. Now the product is z is equal to xy. Okay, so bring it to one variable form. So z is equal to x into this y is 24 minus x. Okay, so bring it to one variable form. Now dz by dx, second derivative, put this dz by dx 0 to get critical point x equal to 12. Now second derivative is negative, that means it is the point of local maximum. Okay, and by putting x equal to 12, the y, which is 24 minus 2x, will come out to be 12. Number 14 is find two positive numbers x and y such that x plus y is 60 and the product xy cube is maximum. So let us start with it. Okay, x plus y is 60. So p is your product is your, you have to prove xy cube maximum. Okay, so x is your, say you can take either change to y or to x, but as it is means more precise is to change x to 60 minus y, because y is involving multiple powers. So x is 60 minus y, so my product will be 60 minus y into y cube, so it can be taken as 60 y cube minus y4. Okay, so here instead of changing y to 60 minus x, it's better to change x to 60 minus y. So this is my dpy dy, my critical point 0 and 45. Okay, now I will reject this y equal to 0. Why? Because y is should be positive. Okay, so take the other critical point, that is 45. Now I am applying here the first derivative test. If you feel okay, you can go for the second derivative test also, because that is also simpler. So for y less than 45, I'll check my dpy dy. So I'll find here this is positive, and for less than 45 it is again positive, so it is positive. And for y greater than 45, we say 46, so this is positive and this is negative, so it is negative. Okay, so something turning from positive to negative means it is the maximum. Okay, so p is maximum when y is 45 and x can be calculated by 60 minus y, so which is 50. Next is find two positive numbers x and y such that their sum is 35 and product x square by 5 is maximum. So again x plus y is 35, y is 35 minus x. As both powers are involved, so you can go for the simple one as y is 35 minus x. So I'll change better to this y. So x square into 35 minus x raised to power 5. So here I have to apply the power rule. So dz by dx I take, and then to find the critical point, I'll get the critical point as your x as 0, okay, or 35 or 10, okay. But you know x0 is to be rejected and x35 is rejected because your total is your x is 35 is, it will give me, because the total is 35, so if I'll take 35 itself, so my y will be 0. So it's better that the critical point or turning point should be taken as x equal to 10. So I can go for any of the tests which I find suitable. So first derivative test, let us do it by this method, that x is less than 10 means it is less than 10. So my dz by dx, see, for less than 10 it is positive, okay, this is positive, and for less than 10 it is also positive. So it is positive. Second one is greater than 10, it's negative, like 10.1 you can put. So from positive to negative it is the point of maximum, okay, and at x equal to 10 y will be 25. Again, two positive numbers, sum is 16 and sum of whose cubes is minimum. So x plus y is 16, y is 16 minus x. Sum of cubes is your x cube plus y cube. Replace, please change the question to x. You can replace anyone and then apply dz by dx. Critical point will give me x8, okay. Second derivative positive, so that means it is the point of local minimum. And the values are when x is 8. Oh, by replacing in y equal to 16 minus x, I can get my y also equal to 8. A square piece of tin of side 18 centimeter is to be made into a box without top by cutting a square from each corner and folding up the flaps to form the box. Okay, so this is a square box of side 18 centimeter and a box, okay, a box square in the shape from here x, whose length we have taken it as x, is taken out from each corner, removed from each corner, okay. So what will happen, this complete width is your 18, so x and x removed means this portion is your 18 minus 2x. Similarly, this complete is 18, so this removed portion from here to here is again 18 minus 2x, okay. So let x is the side of each four squares cut off from each corner. So the dimensions of open box will be your length 18 minus 2x, width also, and the height factor is x. So it becomes a cube, or you can take it as volume of the open box as z is equal to LBH also can be applied. The same result will be followed. As you know, the third dimension is not same, so instead of taking cube, I'll go for LBH, okay. So this is my z function by opening the brackets. So first derivative critical point, I'll get it as 9 or 3, but 9 is rejected because at x equal to 9, this 18 minus 18 will be cancelled. So I'll take x as 3. Second derivative says it turns out to be negative. That means it is maximum at x equal to 3. So the size of each square to be cut from each corner is maximum, to have maximum volume is 3 centimeter. Question number 18 is same question. Now here instead of square box we have taken the rectangular sheet, okay. So this is rectangle, so this complete length is 45, so after removing x and x we'll get it as 45 minus 2x, and to this way it is 24 minus 2x. So volume will be your L, B, B and H. So altogether after opening it becomes this. So dv by dx, this is d square by dx square, d square v by dx square. After finding the critical point, x is 5 and 18, okay. 18 will be rejected as it will give me the width negative, 24 minus 2x negative. So x is equal to 5 is the only option. So second derivative at x equal to 5 is negative, volume is maximum, okay. So hence box with maximum volume is obtained by cutting off equal squares of side 5 centimeter. Number 19 is show that of all rectangles inscribed in a given fixed circle, okay, rectangle is inscribed, the square has the maximum area. So that means ultimately I have to prove that this rectangle is a square. That means to prove rectangle is a square, I have to prove x is equal to y. Okay. So let PQRS is a rectangle inscribed in this. Okay. And x is its length, y is its breadth. Both are positive. Now using Pythagoras theorem here, a is the radius. So this is a, this is a. So using Pythagoras theorem, it becomes x square plus y square equal to your 2a whole square, that is 4a square. Okay. Now from here I'll find the value of y. Okay. Now what is the area? It is to be proved your maximum. So area is your length into breadth, area of rectangle. So this is length into breadth. Now I have told you whenever the root sign is involved, to avoid it, what I will do is I'll square both sides, and like a square is x square into this 4a square minus x square without root, and then I'll put it as z. Okay. So open the brackets. This is the same thing. Either you are differentiating a square or z, both are same thing. Means you are differentiating the square of area or the area. Means the rate of change is there. Okay. That same case is there. So dz by dx, d square y by dx square, and then to find critical point, put it equal to 0, x is root 2a. Okay. The second derivative says that the second derivative at this value becomes negative. So means your area is maximum when x is root 2a. Now get back to y. Put the value of x as root 2a. You again get y as root 2a. So ultimately it means your x and y both are same. That is root 2a. Okay. So area is maximum when x and y both are equal to this. And you know that this is the only condition for a rectangle to be a square. Show that the right circular cylinder of given surface and maximum volume is such that its height is equal to the diameter of the base. Okay. So this is your cylinder whose radius is x and height is y. Okay. And given surface means the surface area you have to use, and using surface area means surface area will be used in changing the two variables in the volume to single one. Okay. And prove the volume maximum. So let x is the radius, y is the height. Okay. Both are positive. S is the your area constant, which is your total surface area, the CSA1, and the area of two ends means the total one. So S is 2 pi xy plus 2 pi x square, as it is 2 pi RH plus 2 pi r square. Okay. So here again you divide by both sides by pi. Okay. So that you get S upon 2 pi. Both are not changing. So this is constant, note pi k. From here you can find any of the variables, say y. Now this volume of cylinder is z equal to pi r square h, that is pi x square y, as the height is y here. So it's better now to change the value of y instead of x, as you know that x will involve the square, so my calculation work would have been larger. So z is your, open it, and this will be pi times kx minus x cube. Okay. So this is the first derivative, this is the second. The critical point will give me x is root k by 3. The second derivative says it comes out to be negative at this point. So z is maximum. Okay. And how to get y? I'll come back here. So I'll put the value of k, this x in terms of k. Okay. So I'll again get that y is by, this is 2 times root k by 3. So y is 2 times root k by 3, that is 2 times x. So this was the condition that height is equal to the diameter. Diameter means 2 times radius. So the volume of cylinder is maximum when height is equal to diameter of its base. Okay. Of all closed cans, cylindrical cans, given volume 100 cubic centimeters, find the dimension of can which has minimum surface area. Okay. So you have to use that. The volume is given here. Now as in the previous question, area was given and you have to prove the volume maximum. Here in this case, you have to prove surface area minimum and using the volume concept. So again, let x is the radius, y is the height. Okay. Volume of closed cylinder is pi r square h, which is your 10. In place of h it is y. So y is your 100 upon pi x square. Z is your surface area. So again it is 2 pi r h plus 2 pi r square, like so. Z is your 2 pi xy plus x square. Okay. 2 pi is common. Now put the value of y to change it to single variable. So we come up to here. Now again differentiate first time, second derivative. To find the critical point, put this 0. Okay, so from here we get your value of x as 50 upon pi raised to power 1 by 3. Okay, now check the second derivative, it comes out to be positive, hence it is minimum, area is minimum when x is your this. Okay, and y can be calculated by replacing the value here of x. So we will get, now you are putting the value of x, we can calculate y. Okay, so height y can be calculated like this. A wire of length 28 meter is to be cut into two pieces. One is to be made into a square and other into a circle. Okay, now same question can be asked that this wire which is of 28 meter can be changed to a square or equilateral triangle or circle or equilateral triangle, that type of also, but here it is to be changed into a square and a circle. Okay, what should be the length of two pieces so that combined area of square and circle is minimum? So let x meter be the side of square and y meter be the radius of circle. So length of the wire will be the perimeter part, like 4x for this square and the circumference, that is 2 pi r for circle. So length of wire will be 4x plus 2 pi y. Okay, so according to question, this perimeter is 28. Okay, so y is your 14 minus 2x upon pi. Area is your square, area is x square, and circle is pi r square, that is pi y square. So combined area will be x square plus pi y square. Okay, now change this y from here and it is 14 minus 2x upon pi whole square. Okay, so this area is your this. Now find dA by dx, d square by dx square, and the critical point can be found by equating d by dA 0. So I'll get x as 28 upon pi plus 4. And second derivative says it comes out to be positive, that means area is minimum when x is 28 by pi plus 4. Hence the wire should be cut at a distance of 4x, means the perimeter part, that is 112 upon 4 into this complete, that is 112 upon pi plus 4 meter from one end. Okay, and length of circle is 2 pi r. So when you will put the value 28 minus 4x, you will get it as 28 minus this complete, that is your y part is 28 pi upon pi plus 4. Okay, and side of square is your x is equal to 28 upon pi plus 4 and radius of circle is y, so which can be calculated from here. And the diameter, radius is this, so diameter will be 2 times this complete term, that is 28 upon pi plus 4. So side of square is equal to diameter of circle. Now prove that the volume of largest cone that can be inscribed in a sphere of radius r is 8 by 27 times the volume of the sphere. So again a cone is inscribed in a sphere and the radius of the sphere is r. So this is r, okay, and this is also here r, right? And this is not the radius, don't get confused, this is not the radius, okay? For radius it should touch the end of the sphere. So the radius of this my cone is x and this height is taken here as y. Okay, this AM is y. So what is this OM? This is your y minus r. Okay, as this is my complete y. So this is y minus r. So I'll apply Pythagoras theorem in this triangle. My y minus r whole square plus x square equal to r square, and from here x square is 2ry minus y square by opening it. Now volume is z is equal to 1 by 3 pi r square h, r is your x and y. Okay, now use this x square here to convert the equation in one single variable, that is y. Dz by dy, second derivative, to find critical point put 0, we get my critical point y as 4r by 3. The second derivative turns out to be negative here, that means it is maxima. Okay, and when y is 4r by 3, come back here, put the value here to get x, which is x square is 8r square by 9. Okay, now volume of the cone is 1 by 3 pi x square y, that is 1 by 3 pi, put the value of x and y here. Okay, now combine 8 by 27 all together, and remaining thing is your 4 by 3 pi r cube, and this you know very well, it is the volume of sphere. So I proved that volume of cone is 8 by 27 times the volume of sphere. Show that a right circular cone of least curved surface area and given volume has an altitude equal to √2 times the radius of the base. So again, the question of cone, x is radius, y is its height. Okay, so volume is, now here the volume is given. I have to use this given volume to prove the curved surface area least. So the given volume is, from volume I'll get the conversion of the two variables involved here into single one. So 1 by 3 pi x square y is your v, x square y is 3v by pi, which can be taken as constant k. Okay, and s is the CSA, so which is your pi r l, l is your slant height. Using Pythagoras theorem you can get it. Okay, now again it is involving the under root term, so it is suggested to take square and put this s square as z. Okay, put back the value of x square from here, and the whole function changes in the form of y variable. Okay, so again dz by dy, second derivative, to find critical point put 0, y is 2k raised to power 1 by 3, second derivative at which turns out to be positive, that means z is least, and x square is your k upon y, which you will get the value as y square upon 2, that means y square is equal to 2x square, that means y is root 2 times x, that is the z is least for z, or the s that is least when height is root 2 times the radius of the base. Now show that semi-vertical angle of cone of maximum volume and of given slant height is tan inverse root 2. Again, the question of cone, x is radius, y is height, l is slant height, and this is the semi-vertical angle. This one is the semi-vertical angle. Okay, and using Pythagoras theorem, you know x square plus y square equal to l square, so x square is l square minus y square. Volume is 1 by 3 pi x square y. Okay, x square is l square minus y square, so I'll use it here. So volume is this, open this. Okay, dv by dy, as L is not changing because given slant height means it's constant, so d square v by dy square negative, critical point y is l by root 3. Check the second derivative test, it is turning out to be negative, that means volume is maximum when y is l by root 3, and x can be calculated from here by putting the value of y. So x is root 2 by root 3 l. Now in right triangle, what is the value of this angle? Tan theta is your perpendicular divided by base, that is x upon this y. Okay, so which is your, put the values from here and here. Okay, you will get, turns out to be root 2. So theta is tan inverse root 2. So semi-vertical angle is tan inverse root 2. Show that the semi-vertical angle of right circular cone of given surface area and maximum volume is sine inverse 1 by 3. Okay, semi-vertical angle is this angle. Okay, this angle. This angle is called the semi-vertical angle. Okay, so here this is complete vertical angle, and semi-vertical is half one. Okay, so let us start with, as the surface area is given, so I have to use this given surface area to change two different variables in the volume formula to single variable, and then I will apply the second derivative test to my volume. Okay, so let us start with x is the radius of the base and y is the height. Okay, y is this complete height. So using Pythagoras theorem, slant height becomes x square plus y square under root. So surface area is your total surface area, that is your pi rl plus pi r square. Okay, this is your s. Now I will change my L also in the variable form x square plus y square by using the formula for slant height. Okay, then dividing both sides by this pi factor, s by pi, as it is not changing, it is some constant, say k. So x into root x square plus y square equal to k minus x square. I'm squaring both sides, I'll get it as this expression. Okay, this is k square plus x4 minus 2k x square. So from here x square comes out to be in terms of k square and y square. So my formula for volume of the cone is 1 by 3 pi r square h. So r here is as x and h here is y. So simply I can change this x square by this. Okay, so this becomes a simplified term, right? And then I have to apply the second derivative test. So first is to find dz by dy. Here I have to apply the quotient rule. and then second derivative. My second derivative I'll find, and then critical point by equating this equal to 0. The critical point is y square equal to 2k, that is y is equal to plus minus root 2k. Okay, but y is root 2k as minus negative sign of the height is not possible. Now I can apply either first or second derivative test. So if second derivative looks tedious, I can go for first derivative test. So what I will do is I will check y slightly less than root 2k and y slightly greater than root 2k. So when y is less than root 2k, y square is less than 2k. Okay, take it y square to other side, 0 less than 2k minus y square, that is 2k minus y square greater than 0. That means first derivative is positive. For the second case, 0 greater than 2k minus y square, that means 2k minus y square less than 0 means first derivative negative. So that means my first derivative that changes sign from positive to negative. So what is existing here? Maximum. Okay, so z is maximum and your y is root 2k, and from inputting in the equation of x square, I'll get x as root k by 2. Now alpha was my semi-vertical angle, and from triangle OMB, sin alpha is perpendicular upon hypotenuse. Okay. Now put the values of x and y from here. I'll get the ratio as 1 by 3. Okay, the result as 1 by 3. Sin alpha as 1 by 3. So simply my alpha is sin inverse 1 by 3. The point on the curve which is nearest to the point 0, 5. Okay, now see, it's a parabola, upward parabola. Okay, and this is the point 0, 5, and take a point on the parabola like pxy. Now the distance, this distance we can find by using our distance formula. So it becomes x minus 0 whole square plus y minus 5 whole square. Okay, so by opening, say as it is involving square root, so I have told you whenever there is square root, it's better to start with the squaring. Okay, so z square is your x square plus y minus 5 whole square. Okay, and x square is equal to 2y, so means this will help me in changing this complete to variable y. So let us put this small z square to big Z, so that there is no problem in derivating the function. Okay, we don't want to divide utilize like 2z dz by dx, so write it as complete z. Okay, and change this complete to y by using this expression x square equal to 2y. Now dz by dy is this, second derivative is this, critical point I'll get here from y equal to 4, and the second derivative at y equal to 4 is always positive. Okay, so that means it is the minimum, and the minimum is at y is equal to 4. And y equal to 4, what is the value of x? I'll come back here. X square is equal to 8, so x is equal to plus minus root 2. So my points are root 2, 4 and minus 2, root 2, 4. These are the 2 points which are nearest to given point 0, 5. So that means you can see that option number A here is the correct option. Number 28 is find the real values of x, the minimum value of this function is. Okay, so to find the minimum, again the function, the derivative, I have to use the quotient rule. Okay, so this is the derivative. So critical point is put f dash x equal to 0. I'll get the value here as plus minus 1. So these are two critical points. Okay, so what I will do is I'll evaluate my function at all these points. Like f of minus 1 will be your 3 and f of 1 is 1 by 3. And as you can see that the minimum is your 1 by 3. Okay, so this is how we will do this question. The maximum value of the function between 0 to 1 is, you have to find the maximum value, means out of these options some option is correct, so we have to find that one. So for maximum value, again start with fx, your function. Okay, and write it in simplified form. That means you can just multiply x inside so that you get this term. Then the derivative, you'll get the derivative, okay, by using the power rule, 1 by 3, this complete raised to power minus 2 by 3, and then ddx of this. So this is derivative. And the critical point equating to 0 will get the critical point as x equal to half. Okay, and this half is belonging to my 0, 1, that is okay. Okay, now what I have to do is, as half is my turning point and is also belonging to the closed interval 0, 1, so I have to find the value at f of 1 by 2. Okay, so f of 1 by 2 is your 3 by 4. Okay, because I have to check the values at the end points 0, 1 and at 1 by 2. So f of half is your 3 by 4 is to power 1 by 3, which is less than 1. And at x equal to 0, the value is 1. At x equal to 1, the value is again 1. Okay, so you can see that this value is less than 1, so maximum value of the function is 1 itself. So that means option number C is correct. Maximum value is 1. Okay, and if somebody asks for the minimum value, it is your this one, 3 by 4 raised to power 1 by 3. So please give a good practice to all the questions of exercise 6.5. Then it will be easier for you to understand the concept and apply the knowledge learned till now to solve the miscellaneous exercise. Thank you so much.